All right. Hey guys. Welcome to another video, guys. This is test 5 review. Remember, this video is to help you guys complete the lecture or the review problems that I sent out in the email last week. So if you haven't done the test or you've done the test but didn't do so well, please watch this video to the entirety, work out the problems like I do so you can have the recipe and the steps of how to do the problems when you do them on your own. So test 5, let's go. So there will be cover 6 sections. It will be 20 questions, guys. You have 3 attempts for this test. Please complete this review and the homeworks before you attempt the test, guys. That we can get the highest grade possible. Best of luck to you. Evaluate the expression for the given value of x, negative 5x cubed, x equals to negative 4. So we have negative 5x cubed, but we have x is equal to negative 4, so it'll be negative 5 parentheses negative 4 cubed. We have to evaluate the negative 4 cubed first. Since it's PEMDAS, we have to do exponent first. So negative 4 cubed is pretty much negative 4 times negative 4 times another negative 4. So two negative 4s make a positive 16 times another negative 4, right? Bring that down. Well, 16 times negative 4 is negative 64. So then we have negative 5 times negative 64. Two negatives make a positive. 5 times 64 is 320. And you're done. Do not overthink these, guys. Make sure you're using the rules that we've learned in this class. Remember what power, what exponents do, etc. So that way we don't make any mistakes. All right, let's keep going. Use a product rule to simplify the expression. So remember the product rule, when you multiply the same letter, we have to add the exponent. It's x to the m times x to the n. We add the exponent. So I'm not going to show all the rules because I did that in the lectures, but remember what the rules are. So we have the same base here, so we're just going to do 9 plus 4 to get the solution, which is just to the 13th power, and we're done. Now if you wanted to know why is it 13, well, y to the 9 means there's going to be 9 y's. 4, 5, 6, 7, 8, 9. Here we have 4 y's. 1, 1, 1, 2, 4. And in total, how many do we have? 13. So there's two ways to do it. You can write them all out, add them, or you can just add the numbers, whichever you prefer. See how the rule, using the rule made it easier? Number 3, use a product rule to simplify the expression. Write the result using exponents. So we're multiplying this. This y has an invisible 1 that you don't see. So there's two product rules we're going to apply. We have the x's, right? X is to the 12 plus the 15, right? 12 and 15 times y to the 1 plus 8, right? Because the 1 and 8 are different. So then we have x to the 27 times y to the 9th. And there you go. That's the answer. You just add the exponents, keep the alphabetical orders, x and y, and we're done. Do not overthink it, okay, guys? Product rule is just adding exponents. Quotient rule, subtracting exponents. Power rule is multiplying exponents. Zero exponent is to the 1. And you'll see that we do it go, okay? Don't overthink it. Use the power rule to simplify. Here's a power rule. So that's a power to a power. So when we do a power to a power, we multiply the exponent. It'll be 9 times 7, which is c to the 63 power. So power rule is we multiply the exponents. All right. Number 5, use the power rule and the power product or quotient to simplify the expression. Some of the bases are not equal to 0, so p over q to the 4th power. When you have a fraction to a power, you just pretty much put the power to the top and the power to the bottom, and we're done. All right. Find the degree of the polynomial and determine whether it is a monomial, binomial, trinomial, or none of these. So look at the polynomial. So remember, the degree determines the exponent, right, with the letter. So this x has a 1. So the degree is 1. When it is degree 1, it's also called linear. So that's degree 1. And then there's two terms, 8x and 7. So by monomial is 1, binomial 2, trie is 3, or none of these. There's 2, so it's going to be a binomial. And you're done. Do not overthink these. Remember, I did give examples on these in the lecture, so do not overthink, you guys. If you haven't seen the lecture for the chapter 12 notes, make sure you're just writing down what I'm doing and understanding why I'm saying what I'm saying. So it's linear, it's degree 1 because the x has an invisible exponent of 1. That's the highest degree. Remember, degree is the highest exponent. And then binomial is because there's two terms. And terms are separated by plus signs and minus signs. So if p of x equals x squared plus x plus 5 and q of x equals 9x squared minus 5, find p of 6. So they want you to find p of 6. So we're going to use this formula here. Wherever there's an x, I'm going to plug in 6. So it'll be p of 6 is equal to 6 squared plus 6 plus 5. Use PEMDAS. 6 squared is 36. Bring down everything else. Add and subtract from left to right. So then we get 42 plus 5, which is just 47, and we're done. Simplify the polynomial by combining like terms. They're all x terms, so we can add and subtract from left to right. This 2, 10x minus 11x is negative 1x plus 9x. When we combine those two, we get a positive 8x. And we're done. Bless me, sorry about that. Number 9, perform the indicated operation. So we're just adding two polynomials. So since there's no numbers to distribute, we're just going to drop the parentheses. So we have negative 6x minus 5 minus 2x squared plus 6x plus 1. Now look at what we can combine. We can combine this negative 6x with this positive 6x. We can combine the negative 5 with the plus 1. 2x squared stays by itself. We want to write the highest exponent first, so that goes first. Now we combine the 6 x's. You owe me 6x, but you have 6x, so they cancel out. Negative 5 plus 1, you owe me 5, but you give me $1, so now you just owe me $4, and you're done. So adding polynomials is just combining like terms, guys. That's the simple truth. So do not overthink combining polynomial or adding polynomials. Just combining like terms. Subtract the given expression. Now this one's a little trickier because you have to distribute the minus sign because there's a negative 1 right here that we're going to distribute to all of this. So bring down the 7x squared plus 12 on its own. When you multiply negative 1, the signs flip. So positive 4x squared becomes negative 4x squared. Negative 5 becomes a positive 5. Now what can we combine? We can combine this with this. And then we can combine that with that. So 7x squared minus 4x squared is positive 3x squared. 12 plus 5 is positive 17. Subtract again, so go ahead and distribute the minus sign, right? So then remember the signs flip, so 9x squared becomes negative 9x squared. Y squared becomes negative y squared. Negative 12 becomes plus 12. Bring down everything else and combine your like terms. So I'm going to highlight. So 4x squared can combine with negative 9 squared, right? Because they have the same. Y squared can combine with negative y squared. And negative 8 can combine with positive 12. So 4x squared minus 9x squared. So you have 4, but you owe me 9. So you still owe me the 5 if you pay me off. The y squares cancel out because it's the same thing. You owe me $8, but you found 12, or you got paid 12, so you get $4 left to your name after you pay me the 8. And you're done. Multiply. So here we have a power rule. I mean a product rule. We're going to multiply, but we have to multiply the negative 6 and the 8. So what this is pretty much negative 6 times 8, and it's going to be n to the 9 times n to the 4th. And we know right here we're going to add the exponents, right? Because we're multiplying, so it'll be 9 plus 4. Here we have to multiply, which is just negative 48. So it's negative 48 n to the 13th power, and we're done. So you have to multiply the outside numbers at the exponent. So there's a lot going on, but you can break it down on your own, okay? So please do not overthink this, okay? Do not. Multiply. This is a distribution, so we're going to distribute 7x to these two. 7x times 9x is 63x squared, right? Because it's x and x. 7x times 4 is a positive 28x, and we're done. Because we cannot combine these at all, because they have different terms, x and x squared. We're gonna double distribute here, or we can do a box method or FOIL. All right, so I'm gonna go ahead and do a box method to show you how to keep your work organized. X plus 4, x plus 8. X times x is x squared. X times 4 is 4x. 8 times x is positive 8x. 8 times 4 is 32. So we can combine these two. So then we get x squared plus 12x plus 32. And we're done. Now, if you don't want to do the box method, guys, you can just do the FOIL arrow. So you do x times x, which is x squared, x times 8, which is 8x. So 4 times x, which is 4x, and then 4 times 4, which is 32. Combine your like terms, and you get the same solution. Either method works out, guys. Here is 4x, 5x squared plus 4 squared is pretty much 5x squared plus 4 times another 5x squared plus 4. So I'm going to go ahead and draw an arrow for the first one. This is F, the FOIL. So then this is going to be 5x squared times 5x squared, which is 25x to the 4, right? Because we add the exponents. Then we do this times this, which is the O, which is 5x squared times 4, which is positive 20x squared. And we do another 4 times 5x squared, which is the I, which is positive 20x squared. And then we do 4 times 4, which is the L, the last terms, which is a positive 16. Combine your middle terms because they're like terms. You're just going to add them, which is just 40x squared plus 16. And you're done. Here we have a minus 4, a plus 4. Go ahead and FOIL it out. A times a is a squared. A times 4 is 4a. Negative 4 times a is negative 4a. Negative 4 times 4 is negative 16. These cancel, so then we get a squared minus 16, and we're done. 3 to the negative 4. We do not like a negative exponent, so whenever we have a negative exponent, x to the negative m, you just move it to the bottom of the fraction and it becomes positive. If you have a negative exponent on the bottom, you just move it to the top and you're done. And it becomes positive. So this is the rule. So within 3 to the negative 4 is pretty much 1 over 3 to the 4th, which is just 1 over 3 times 3 times 3 times 3, which is just 1 over 81. And we're done. So this is not a less than, guys. This is an equals. My apologies. Let me erase that and fix that. So this is an equals to. All right, we're almost done, guys. You're doing great. Simplify the expression. So here we have 5 to the negative 1, which is just 1 over 5 to the 1, which is just 5, plus 1 over 6. We have to add the same fractions, so let's go ahead and get the same denominator. So we know 5 and 6, the LCD is 30. Right? So we're going to go ahead and multiply 30. So it'll be 30 times 1 over 5 plus 30 times 1 over 6. So 30 times 1 . Well, to add the fractions, we want to get the same thing, right? So let's see, what if I don't do LCD? What's another way I could do this? Because I want the same denominator to add, right? So if I want the same denominator, I want to make this into a 30, right? So I'm going to multiply this by 6 over 6, right? Because this is the other denominator. And I'm going to do this 5 over 5. When I do that, this is going to be 6 over 30. And this is going to be plus 5 over 30. Yep. So 6 times 1 is 6. 6 times 5 is 30. 1 times 5 is 5. 6 times 5 is 30. We have the same denominator, so we get 11 over 30. And we're done, because we can now simplify that. There you go. Don't do the other method I did. This is the one I want you to do. Alright, so whatever the fractions are, multiply the other denominator to the other one, and the top and the bottom, and then you get the same denominator, new numerator, and just combine your top. 6 plus 5 is 11. The 30 stays there. Perform division. So then we have 17x to the 9 over x plus 9x8 over x. So here we have 1 and 1. The quotient rule is we subtract the exponent. So 9 minus 1, so it'll be 17x 9 minus 1 plus 9x 8 minus 1 because we're subtracting, right? So then it'll be 9 minus 1 is 8 plus 9x to the 7, and we're done. Because the quotient rule is subtracting the exponents. So here we have the same thing. So we have negative 32x to the 5th over 12x to the 6th plus 60x to the 6th over 12x to the 6th. This is the same thing here, so they're going to cancel out. 60 divided by 12 is 5. Here, negative 32 over 12, they don't divide evenly. 5 minus 6, so it'll be x to the 5 minus 6. Negative 32, 12. I can divide both of these by 2. So this would be negative 32 would be negative 16. 12 divided by 2 is 6. I can do this again. So I just divided by 2. So I'm going to divide by 2 again. So then we get negative 8 over 3. X to the negative 1 plus 5. X is negative, so we have to move it to the bottom of the fraction. So then we get 5 first minus, because it's negative 8, right? So it'll be negative 8 over 3x, and we're done. So we did the quotient rule by subtracting the top minus the bottom. So 5 minus 6 is negative 1. When we have a negative exponent, it goes to the bottom. 1 is just invisible, so I don't have to write the 1 if you don't want to. And we're done, y'all. So you're gonna have a problem like this. So pretty much the first step is to put the 12 with you have to divide it out. So what you want to do is you want to get 12 divided with this one, and then 60 divided with this one, which is how we did this step here. So 32 over this, 60 over this. So, and then you use the quotient rule, x over 6, that's 6 minus 6, which is 0. So 6, so when you do right here, just to explain this part right here, why I cancel these out, it's the same thing, right? But x to the 6 minus 6 is just x to the 0, which is just 1. So this does go away. So don't overthink that. And we're done, guys. We're done with another review. Make sure you watch this or watch me work out any problems again. You can do the same process, same steps to the problems on the exam, on the test that you'll be taking. So good luck, everyone. Peace and love, everyone. Good luck, and I'll see you for the final review. Take care.